I'm back with part 2, just some more extensions of the activity we did today. Like I said, the teacher and me, I talked way too much. Even on a video where I'm uncomfortable, I end up talking too much. So nothing new there. My students would definitely tell you, oh yeah, Miss Dixon, she talks all the time. Anyway, check out these extensions. See what you can come up with your own. I'd love to know some other activities you did with these things. Math is everywhere, and math is in our homes. And it's just a great way to practice, especially when we're going to be off school for a while. So I hope you enjoy and keep working on your math skills. Thanks. So here's another question for you. What if I wanted to take and find the difference between the greatest cost item and the least cost? So the greatest cost items, if you remember on my problem, was the shells and cheese at $6.48, I believe. Let me find it on my list. Yes, $6.48. And my least cost was the beefaroni. It was 94 cents. And I want to find the difference. I'm going to subtract. When I'm subtracting, this is something that I found that 5th graders sometimes forget if they haven't done it in a while, is that I need to line my decimals up for the subtraction problem. So if you want to find the cost for your greatest item and the cost for your least item and find the difference between them, just subtract them. When you're subtracting decimals, please make sure you line them up. If I went to put 94 cents over here, my decimals are not lined up and I'm not subtracting from the same place value. So I always, when I write this out, I always like to say, I've got 2 decimals. I'm going to go ahead and line them up. One is $6.48. That's the greatest amount. And the other one is 94 cents. And that would look like this. And it may look a little funny, but what you can do is, I am lined up with my decimal. I can add a 0 under the 6 like I did when I compared them. I like to go ahead and put my decimal in my answer so it's there and I don't forget about it. And then if you wanted to round and say, hey, $6.48, that's close to $6. This is close to 1. My answer is going to be 6 minus 1 is 5. So my answer is going to be around 5 something. I always like to estimate. I think that's a great tool to use for our kids. So anyway, let's go ahead and subtract these. We can subtract 8 minus 4 pretty easy and get 4. And then when I go to 4 minus 9, I cannot do that. I cannot subtract 9 from 4. In 5th grade, we like to do the traditional method, which parents should be happy about. We like to borrow from the 6. We're going to borrow 10 from it, because each place value is 10 times larger, so that's a 5. The 4 becomes 14. Now I can do 14 minus 9. And 14 minus 9 is 5. Okay? Because 10 minus 9 is 1, and I had 4 over here, so 5 left. And then 5 minus 0 is 5. So the difference between these two is $5.54. You can take any of your numbers and find the cost difference. You could also, if you really want to challenge, you could add your total together. You could add all your decimals together and get a total. If you want to see that with my amount, then I can show you that in the comments to see if you were right, if you wanted to add the total of the items that I have found. Another cool activity you can do just to keep practicing with decimals and number literacy is or money literacy, I should say. When I'm in a store, I don't pull my phone out and start calculating my total. I usually like to round my total to make sure I have enough money when I go to pay. I tell my students all the time, this is a great tool to use when you're in a store. This is real life. You don't want to get up to the cashier and be like, oh, I need to put this back. I don't have enough money. So I like to round my items as I go through the store. So if I had sprinkles that was $1.79, I like to round to the whole number. So I can look next door and say, okay, the 7, we always say if it's 5 or more, you raise the score. If it's 4 or less, let it rest. That's what we like to say. So this is definitely 5 or more. This is 79 cents out of $1. I am closer to $2 than I am to $1. So this would round up to $2. Okay. I could also take my corn pops, which was $2.99. I'm going to round to the nearest whole number, and most of you can see that $2.99 is like 1 cent away from $3. So it's definitely closer. If I had a number line, it's definitely closer to $3 than it is to 2. So that's going to round to $3. Now let's find one. It's a little different. Let's use the Lysol wipes. It was $4.16. Rounding to the nearest dollar. Let's see. I did this. Whoopsie. I should have drawn my line here like that. Sorry. Rounding to the nearest dollar, the 1 is not going to round the 4 up. It's actually closer. If I was to draw a number line, it's closer to $4 than it is to 5. So this one actually would round to 4. So you could take all of your items and you could round them. Practice saying, is this closer to $5 or is it closer to 4? Which one is it closer to? And start rounding those to your nearest whole number. For unit price, I think we had the shells and cheese that was $6.48, and I said, what if I wanted to see what it would cost for one of those? So my students would say, if I want to know the cost for one and I have 3, I need to divide. Now when you divide decimals, if you do not have a decimal in your divisor and you have one in your dividend, you can bring it straight up, okay? So I can divide. 3 goes into 6. It goes twice, which is 6. I subtract and get a 0. I'm going to bring down my 4. 3 goes into 4 one time, which is 3. Subtract, you're going to get a 1, and then you can bring down 18. 3 goes into 18 6 times. This goes in evenly. Couldn't have worked out any better. So the cost for one box is $2.16. Now what you could do, and I probably should have done this in the store to see if I was being a good buyer, you could compare the cost for one box of your shells and cheese and say, hey, if I bought 3 and each one cost $2.16, but one box costs like $1.79, did I make a good purchase? In that case, it wouldn't be. But if I bought 3 and each one costs $2.16, but the cost for one box, if I just wanted to buy one on the shelf, was like $2.28, then I made a good purchase. So being a conscious buyer is a great tool to learn at a young age. So you could also do that with your math. Okay. Another quick activity you can do with your list today is to practice multiplying with decimals, especially those kids that are ready to do that. It's one of the harder concepts we do in 5th grade, just knowing what to do with your decimal, especially when it's a decimal times a decimal. With today's question though, I could say, okay, which item do I want to buy in bulk? Well, if I was looking at that list, the teacher in me is always going to pick pencils because we need so many of them. So let's take the price of the pencils, which was $5.97, and let's say I wanted to order enough for a week. I don't know, probably a little less than this, but let's say I wanted 6 boxes. So I would multiply by 6. Now, one of the things when you're working with decimals, a lot of kids want to say that, oh, you always line up your decimal. True with adding and subtracting, but when you're multiplying, you actually ignore it until the very end. This question, you know what, let's make this a little bit more difficult. Let's say I want 12 boxes because I want more work here. So let's go ahead. We're going to take the $5.97. We're using traditional algorithm with this, and we're going to multiply it by 2. So I'm going to do 2 times 7, which is 14. 2 times 9, which is 18 plus the one I carried, is 19. 2 times 5 is 10 plus 1 is 11. I'm not finished. I like to get rid of those or mark them out, however you want to do it. And I need to multiply by the tens place. Well, when I multiply by the tens place, I always tell my kids I got to get there, so I need that placeholder. And now I'm multiplying by 1, so that's not a hard problem. So we'll do 1 times 7, 1 times 9, 1 times 5. Now we are ready to add our partial, I guess you call it partial products right now. So we'll do 4 and 0, 9 and 7 is 16, 1 and 9 is 10, plus the 1 is 11, 1 and 1 is 2, plus 5 is 7. Now, it doesn't make a lot of sense to say that my pencils cost me $7,400 $164 because I've not placed my decimal yet. And a lot of kids want to bring the decimal straight down, which is not something you do, especially if there's a decimal right here. Let's say if I wanted to buy like 1.5 boxes, then I would have a decimal here, or 1 2/10 of another box, which pretend you could do that. I could go to the store and buy, hey, I want 2/10 of that box. But anyway, so I always count my decimal numbers. That's where I'm going to move my decimal. 5 is not a decimal number. 9 is. 7 is. So I need to move it 2 places. So it'd be $71.64. What if I could, so that'd be my decimal right there. What if I could say, I'm going to the store, I want 1 2/10 of another box, and I had a decimal here as well. Well, now it's not 2 decimal place values, it's now 3. So that decimal would take one more step, and that'd be like $7, and you'd have to round $7 and around 16 cents. So you can practice with decimals that way. You can make up questions if you have siblings at your house. You can make up questions using your items in your list, like adding them together, subtracting them, multiplying if you wanted more than one item. There's all ways you can practice this. So try it out and see what you come up with. Okay, area models, because I know we're having those show up on our NTI days in Simple Solutions. So I wanted to show you in case you have forgotten how to do area models. I have a question for us. It's 1/4 times 2/3. And we just have to remember that when we're multiplying a number that is less than 1 by another number that is less than 1, our answer is actually going to become smaller, because we've talked about it a lot. When we multiply by 1, the answer stays the same. But if we multiply by a fraction that's less than 1, our answer is going to get smaller than the other factor. So if both of them are less than 1, our product's going to be even smaller. So the issue is, I don't think you're going to have trouble multiplying. You'll multiply straight across. You'll simplify if you need to. But our 5th grade standard says we have to do area models. So to do this area model, and I'm talking quick because I don't want my video to be too long, is we're going to take 1/4 and we're going to break our whole number. I already drew an area model, a whole number, into 4ths. So I like to start this way. If I break it into half, now I can break it into 4ths. And so this is a 4th, this is a 4th, this is a 4th, and so forth. I have one of those. So I'm going to take, if I had a pencil, I would lightly shade this in. It's a little harder with Expo markers. So there is 1/4 shaded in. Remember, I'm not Picasso. My shading is not great, but you can see how it's going to work. So that represents 1/4. Now I'm going to make vertical lines to show 2/3. So here's a 1/3. And here's a 1/3, but I have 2/3. Now I've taught my students to make dots. We're going to shade lightly going one way, but we'll make dots to go the other way. So going down, can you see that? Yeah, there's a dot. So that represents 1/3, but I need 2/3, so I've got to go again. That represents 2/3. Where our answer is shaded and it has a dot, that's where our product is. So we are shaded and we have dots right here. We have 2 of those. So we know it's going to be 2 as our numerator, and we're broken into 3, 6, 9, 12 total pieces. So the answer is 2 12s. And I know most of you could go, oh, 1 times 2 is 2, 4 times 3 is 12. But to show the model, that is how that model looks. And I know you have to draw one of those in your NTI Day 5. We could, of course, simplify this. We would divide by 2, and the answer would finally be 1/6. So just a quick refresher on area models. Remember, make some comments on our Google Classroom if you need to see some other things to help you get through those. All right, miss you guys. See you soon. So those are our activities for today. I hope you enjoyed it. It's keeping your math skills sharp. I'll try to do more of these, and I'm sorry I get nervous when I talk in front of a camera. So if I misspoke or something didn't make sense, just leave me a comment and I will clear that up. All right, see you next time.